In this video, we'll be reviewing what we know about factoring, and we're going to factor a polynomial that's a little bit more complex completely by mixing together the greatest common factor strategy and our factoring trinomial strategies, which we tend to refer to as the ABC strategies. So if you look on the screen here, you will notice that we have a slightly more complex polynomial than we've factored in the past. You'll notice that they each contain an x and that the coefficients of each term are a little bit larger than what we've seen before. So here what we're going to do is, since we have these more complex polynomials, we're actually going to mix a couple of factoring strategies together. And when we factor, the first thing we always want to do moving forward is we always want to check for a greatest common factor. So what we're going to do here is we're going to look and we're going to see greatest common factor numerically and variable-wise. What's the greatest common factor that we have? And what I notice is that both 8, negative 32, and negative 40, those are all divisible by 8. So a part of my greatest common factor is going to be 8. And then I also notice that they each contain at least one x. So my greatest common factor here is 8x. So what I'm going to do here to start is I'm going to factor out, or essentially undistribute, that 8x value. So as I do that, the 8 divided by 8 gives me 1, x cubed over x. We subtract the exponents there, so we get x squared. Then negative 32 divided by 8 is negative 4. X squared over x to the first leaves me with x. And then negative 40 over 8 is negative 5, and then the x's cancel out. So now I've factored out 8x, and I'm left with this trinomial here of x squared minus 4x minus 5. And I have to decide if I can factor that fully. Now, because it's a trinomial, we know that the ABC strategy works here, so we're going to explore the ABC strategy and see if that will help us to factor this further. So we have a is equal to 1, b is equal to negative 4, and c is equal to negative 5. Now remember, with the ABC strategy, if a is 1, we have a shortcut that we can use. We don't have to go through the full process. Now remember, our first step here is we want to find two numbers that multiply to whatever a times c is. So a is 1, c is negative 5. So we need two numbers that multiply to a times c, which is negative 5, and add to our b value, which is negative 4. So we need two numbers that multiply to negative 5 and add to negative 4, which are negative 5 and 1. Now, because this has an a value of 1, remember, we can use the shortcut here, and we can split this up into x minus 5, because that's our first value, times x plus 1. So remember that a value being 1 is really helpful. It allows us to use this shortcut here. And then the 8x, remember that we factored out first, gets carried down. So here we can see that we started off by factoring out our greatest common factor of 8x, and then we used our factoring trinomial strategy with the ABC strategy to factor that further to be x minus 5 times x plus 1. And at this point, our polynomial is now fully factored. Now, if you don't remember the greatest common factor strategy or the ABC factoring trinomial strategies, please go and review previous videos, as those will walk through those strategies in a little bit more detail. But hopefully you're remembering those strategies and you're able to see how the two of them tie together to allow us to factor out these slightly more complex polynomials. So let's look at a second example here. What I notice about this polynomial is that the numbers of 5, 30, and 45 have a greatest common factor of 5. So I'm going to factor that out right away because that's going to make this a little bit easier to look at. Then from there, I also notice that they each contain at least two y's. So I have a y squared, a y squared, and a y squared. That can all be factored out. So my greatest common factor here to start to factor out is a 5y squared. So if we factor out 5y squared, I'm left with 5 divided by 5, which is 1. 4 minus 2 is 2, so we have 1y squared, plus 30 divided by 5 is 6. Y cubed over y squared leaves me with y to the first, plus 45 divided by 5 is 9, and the y squareds cancel. So we can see just by factoring out the greatest common factor, we were able to factor out 5y squared, and now we're left with a trinomial here, still on the inside of my parentheses. Now, because this is a trinomial that contains a y squared, I want to see if I can factor this further. So I'm going to take a look at it, and I notice that I have a equals 1, b equals 6, and c is equal to 9. Now, remember, as we talked about on the previous page, when a equals 1, we have a little shortcut that we can use here. So we need two numbers that multiply to be what a times c is. So we have 1 times 9, which is 9, and add to be b, which is 6. So we need two numbers that multiply to 9 and add to 6, which I come up with as 3, 3. Now, because our a value is equal to 1 here, we know we can use our shortcut and factor this to be y plus 3 times y plus 3. So remember that a value shortcut is really helpful because if a is 1, we can really quickly factor this polynomial further. Now, we can't forget that we factored out a greatest common factor to start, so we need to bring that 5y squared back down into the problem. But at this point, we have now fully factored our polynomial. We started off factoring out the greatest common factor, then we used what we know about the ABC strategy to factor this polynomial fully. So let's take a look at one final example. So again, here we notice that we have some larger coefficients for the x to the 6th, x to the 5th, and x to the 4th. So what I'm going to do here is I'm going to look for a greatest common factor. And what I notice here is that all of these numbers are divisible by 2. So I'm going to factor a 2 out in front. Then from here, I'm looking at their variables and what they have in common, and I notice that they at least have an x to the 4th in them. So my greatest common factor here that I'm going to factor out in front of this polynomial is 2x to the 4th. So 6 divided by 2 is 3, x to the 6th over x to the 4th. You subtract the exponents and it becomes 3x squared. Negative 4 over 2 is a negative 2. X to the 5th over x to the 4th. If we subtract the exponents, we're left with x to the 1st. And then negative 16 over 2 is a negative 8, and the x to the 4ths cancel out. So our first step here is we factor out that greatest common factor. Then our second step is to factor this trinomial further. Now, we're going to use the ABC strategy here, but what I noticed just from looking at this is that my a value is equal to 3, my b value is equal to negative 2, and my c value is equal to negative 8. Because my a value here is not equal to 1, I'm going to have to use the more in-depth ABC strategy. I won't be able to just use the a value of 1 shortcut, but luckily we know how to do that. So we're going to start because we still have to find two numbers that multiply to whatever a times c is. So in this case, 3 times negative 8 is a negative 24. So I need two numbers that multiply to negative 24 and add to my b value of negative 2. So two numbers that multiply to negative 24 and add to negative 2, we have negative 6 and 4. So those are our two numbers that are going to help us to factor this further. Now, remember that when we can't use the shortcut, our next step is to use these two numbers to rewrite our trinomial. So what we're going to do here is we leave the 3x squared, but then we rewrite that negative 2x as negative 6x plus 4x minus 8. So we just rewrite this negative 2x using our two kind of magic numbers there. Then from here, we factor this further by looking at this in pairs. So we group those together in pairs. The greatest common factor of 3x squared and negative 6x is a 3 and an x. So if we factor out a 3x here, we end up with 3x, and then we have 1x left on the inside minus 2. And then the greatest common factor of our second pair between 4x and negative 8 is 4. So we get plus 4 times, left in parentheses, is 1x minus 2. So from here, remember our goal is to see matching parenthesis pieces here. So because we see 1x minus 2 and 1x minus 2, we can group the 3x and the 4 together, and we can say, well, both 3x and positive 4 are being multiplied by that parenthesis piece in common, which is x minus 2. So it's a couple more steps added in when the a value is not 1, but we are able to factor it by using our ABC strategy. Then from here, our last step is to bring the greatest common factor down, since that was our first step in factoring this polynomial. And from here, we have our final answer. So again, we start off by factoring out that greatest common factor. Then we utilize the ABC strategy this time because a wasn't 1. We had to be a little bit more involved in the process. We couldn't use the shortcut, but we still were able to reach a fully factored polynomial form by using those two strategies together.